time, sorry, that Thursday's class timing. Your CR asks to change the time. Okay, I don't have any problem.
Sir,
Okay.
could it be from 1:10 to 2 p.m.? Because the last class ends at 12. Sorry, ends at 1.
That's why I told her, okay, you can fix the time even any time. Okay, 110 or 120, it's not a problem for me. Okay, no, you have to
Okay.
decide and you have to inform me. Okay, so today we'll start now. Okay, next week onwards, you just fix the time. Okay, and then you just inform me. Okay. Screen is visual.
Yes, sir.
Good. So today only theory based class. Okay, some definition and theory based, it is based on two theorems. Okay, so just you have to we will discuss the statement of the theorem and proof of the of these two theorems. Okay, before that already we have studied two function. One is Heaviside function. Okay, another one is periodic function. Okay, now today the third function is impulse function. Okay, impulse function. Okay, what is impulsive force? What is impulsive force? You should know that one. Okay, what is that? What is this? You have not heard that one, I think so.
Force
Sir,
is
the
all in
force
front
which
of
acts
time.
Mechanical
at
people
particular
will
time.
answer immediately. Yeah, only one fellow, not all 3-4 fellow together. One fellow, anyone. Now all are silent. Okay, tell me, quick.
The force that acts in very short interval of time is called impulsive force, sir.
Good. One example, Sanjay.
Sir, throwing ball in a wall on a wall.
Okay. Uh, do you have any cricketer in your this class? Who are representing institute? Oh, now everything is offline. Sorry, online. So, yes, one more example.
Player catching a ball.
Tension in a string.
Okay.
Tension in a string.
Okay. What answer? What is that? What they are writing? Okay. So that means okay, very a small instance you are if you are putting some force on any object. Okay, na. So time, if it is say t equals to 0.01 second or something. Okay, na, even that is small time. Okay, na. If you force any, if you apply any force, that is actually impulsive force. Okay, so if you think about cricket bat and ball. Okay, na, when you are that time is very short time. Okay, na. So for 6 or 4 or a good shot. Okay, na. So that one actually very small time, their impact is much, but time is very small. Okay. So that type of if you that this type of force, okay, if you are able to write a function, okay, this type of action, okay, then that function you can write, you can tell that impulse function. Okay, so based on that, actually that name is also that impulsive forces from that one. Actually, the name is impulse function. Okay, so what is the form of that one, mathematical form of that function? Okay, so say phi of t is the pulse function. Okay, so what is that one? So this one, this is the function and it is denoted by phi of t. Okay, then the definition, okay, phi of t is phi of t definition that you find. Okay, 0, we can write different form. Okay, let's just t greater than 0, less than a minus half of t, capital T, it is a by t if, okay, if t greater than equals to a minus half of t, less than a plus half of t. Okay, and 0 if t greater than a plus half of t. You can write simply a phi of t to 0. Okay, sorry, a by t if this one, otherwise 0. Okay, so this is the time. So what is the time interval? Is small time interval, capital T. Okay. So if capital T a small time interval, okay, what is the phi of t? That this function, okay, if you write simply this function, then it is not a pulse function. It should satisfy one condition. Okay, so what is that condition? It should satisfy one condition, that is minus integration minus infinity to infinity. Okay, phi of t dt equals to a, sorry, this is always a phi of t. So this is impulsive function. The integration, if you take the impulsive function from minus infinity to infinity, okay, it will give the a one value a, correct? So what is the graphical form of this impulse function? That is, okay, just wait, before that, okay, if we write capital a is 0, small a is 0, then what is the form? So small a is 0, so t greater than 0. Okay, and what is the difference if t is 0 and a not equals to 0? A not equals to 0 means the function, that graph of this function is actually at a particular point. If a equals to 0, then it is around around origin. Okay, so what is this? So let us see, this is t and this is phi of t. Okay, then if it is t is 0, sorry, a is non-zero, if a is non-zero, then it is a here, say, and the range of that function, okay, so range of this function minus half of t to half of t, so the total range is capital T, correct? So this one is, say, okay, minus half of t, and this one is, say, okay, plus half of t. So at that time only the function value is there, rest part the function value is 0. Okay, so this one is actually a, from a, if you consider left hand side minus t by 2 distance, and from a, if you consider right hand side plus t by 2 distance, okay, t by 2, then that is the function defined. Here it is how much it is, a by t, so this is, say, a by t. So the form, what is the function form? This one only, sorry, this one only, say this one, rest part is 0, so up to this one, this is actually the function. So if graphical form of this one is just this one. Now if you consider a is 0, then also the function is defined. Okay, and in that case it is around 0 only around origin. Okay, around origin it is t by 2. This one is same distance minus t by 2, and this is phi of t, and it is t. So this one is say a by t, the height, okay, or height of that one. So this is the function. This is the function. Rest part is 0. So rest part is 0. This is the graphical form of the pulse function. Okay, the impulsive function whose so here it is, what is the height of the function? That means y value. Okay, we are actually familiar with x and y form, correct now? So phi of t, if phi of t, what is the value of phi of t? Highest value is a by t, correct? So if the magnitude is unit, means 1, okay, then it is called unit impulse function. That one particular name is there. Okay, so when t is a by t equals to 1, that means the highest value is 1, then this function name is, okay, so in the case of this one, t to phi of t, so earlier we have discussed this one is a highest height, that is a by t. Now if it is 1, okay, and then the function is defined, so this is 1. So in that case, the earlier function definition, okay, that is impulse function, okay, impulse function, that will change to, okay, it is called unit impulse function, okay, function. And this one, another name is there. The name is, what is the name? You have studied, okay, Dirac delta, okay, delta function. So what is the notation of this function? I know you have studied. Sometimes it is only, you can say the delta function, okay, delta function. What is the notation of this function? Surely you have studied in first year itself. Okay, first year, first sem. Okay, so if the when unit that means highest height is 1, but there is no change if a is not equals to 0 and a is 0. Both the cases is okay. Okay, so now we have to discuss the Dirac delta function. Dirac delta function is the function. What is the form? I'll write. Oh, sorry. All right. So the mathematical form. Okay. So the mathematical form of this one. Okay. Of Dirac delta function is, what is the function? Del of, it is notation capital del t minus a equals to 0 for t not equals to a. Okay. Or with the condition, okay, otherwise it is 0 with the condition, okay, this condition should satisfy, okay, with the condition. What is that one? Now condition already we have discussed, minus infinity to infinity, okay, del of t minus a dt equals to 1. So this integration if equals to 1, then this one is called Dirac delta function. So this one, okay. Now so if you put a equals to 0, then it is well known for you, I think so. If a equals to 0, t equals to 0, so that means t equals to 0 or t not equals to 0. Okay, so then what is the mathematical form of this? Okay, this function, that is called next one. Sorry. Then what is that form? This form is next one. Okay, right on. Then del of t. So this is again this function, the delta function. D del of t equals to 0. Okay, if t not equals to 0, okay, infinity if t equals to 0. But the condition now, that should be the same condition. Okay, now the constants, it must satisfy the identity, that one, the earlier one we have already discussed, integration. Okay, it must satisfy, okay, must satisfy the condition or restriction, anything you can say, minus infinity to infinity, del of t, okay, del of t dt. So minus infinity to infinity plus infinity, okay, that is, it is del of t dt equals to 1. Okay, so this function, that dd function, direct delta function, having one very good property, that is called shifting property. Okay, so now I will write in the next page, not in the same page. Okay, just tell me, can you answer it? What is the integration value? Minus infinity to infinity. This is called, okay, I will write letter f of t, any function, okay, integrable, okay, del t minus a dt. What is the answer? Minus infinity to infinity, del of t minus a dt. Okay, this one. What is the answer? I will show you the previous slides. I have not written here. Okay, one more slide should be there. Okay, 1, 2, 3. Now answer.
F of t, yes, sir.
It is f of t. Anybody else? What is your roll number, beta? Correct.
Sir, 62. Sir.
62. Okay. Okay, I will just 1 minute. Not 1 minute. A few seconds. I will write. Any other answer?
Sir, actually,
1 or 0? Yeah. I'm not telling
sir,
that
we'll
this
have
is
to
wrong.
need
Okay.
f dash of t and all. We won't need a sir. Like,
Yeah.
we'll do UV rule, sir.
1 minute. Just wait. What is the integration variable here? Left hand side.
Sir, we can integrate our Dirac delta function, sir.
No, but wait. What is the integration function here? Sorry, integration variable.
T.
And if you integrate some function, and then what will be the answer?
Some number should come.
So are you getting the variable again?
Yes,
Now
sir.
you should answer.
1 second, sir.
Yeah. Here it is, answer is there. Okay, now. Partially correct. Only one change you have to do.
Sir, f of infinity and all, what will do, sir?
The answer is f of a. Okay.
Oh,
It is
it's
if you,
0, no, sir.
Huh?
Nothing, sir.
Yeah, T. You told T or A?
Sir, I told T only.
Okay. That's why. So now, so integration. This is called actually. So integration minus infinity to infinity. Okay, f of t along with direct delta function. Okay, dt equals to f of a. This one actually, that means without finding this limit. Sorry. Integration. You can find the value of this integration, that is f of a. This is called shifting property or shift property. Okay, now that is shifting property of, okay, properties of deduct delta function. Okay, it is very much useful, that's why I have given box. Okay, now after a few minutes we will use this one. Okay, so now we just see the minus infinity to infinity is there for the case of direct delta. One just a note here. Okay, even if the direct delta dt function is there product, okay, if the limit is finite also, then also it follows the same integration formula, that means rule. Integration alpha to beta, okay, f of t only one condition is required. T minus a dt equals to again f of a. So only the condition is this integration also satisfy. That means the shifting property holds for this dd function if only the function condition is if a is lies between alpha and beta. Okay, if a and a is lies between alpha and beta, then this function also satisfies this one. So not only the that infinite limit. Okay, for finite limit also this function is exist. Okay, we are not going to discuss or how to find this one. We just memorize this one. Okay, it is important. So this one also satisfy. Okay, for the finite limit. Okay, finite limit, but the limit. Okay, in that limit, a should contain in that interval. Okay, so that is the one. Next. Okay, so previous. Okay, so next one is okay Laplace transform of impulsive function. Okay, so this one we have already studied the impulsive function. Okay, now what is the Laplace transform of impulse function? We will discuss. So now Laplace transform of impulse function. Okay, so this one. So what is the impulse function? That is dd function del of t minus a. Okay, so now Laplace transform of del of t minus a, this one we have to find. Okay, so Laplace transform of impulse function, this one. So from the definition we know that it is 0 to infinity. Okay, the function is defined for that. This function is defined even outside of 0 also. When a is 0, and very first definition itself, it is we have already shown that if it is the function is minus t by 2 to t by 2, also function is defined. Okay, so that means negative side also. So if here it is the function is not defined at 0. Okay, since function is not defined at 0, should I go back? Okay, previously. Yeah, this one. What is the function value at t equals to 0? Infinity, correct. So what is the differentiation and what is the integration of that function? Any idea? So there will be a lot of discussion on that. Okay, so that's why I am telling the function 0. Sorry, the limit 0 is given. Okay, so you no need to be much bother on that. So a 0 or 0 plus, if you write, then your answer is correct. Okay, that means the limit at t equals to 0 or t tends to 0, we have to check. Okay, we'll come this point later. First, 0 to infinity, that is the formula of Laplace transform, del of t minus a into e to the power minus st dt. Correct. What is the integration value? So I don't have time to find all this integration, and finally, what is the answer? Surely, you people are not here. Okay.
E power minus 80, sir.
E to the power minus 80. 80 or as?
Yes.
The function is f of t is e to the power minus st. So only f of a. Your answer is correct. F of a e to the power minus as.
Yes.
Should we go back and we have to show again? This one. Just check.
But here in our question, it is from 0 to infinity, right?
Hello. Okay. Oh. Okay. Yeah, I found it. Okay. Okay. He's now here. Okay. Okay. derivative. Okay, so the
Sir.
okay, yeah.
Sir, but here in our question, the limit is from 0 to infinity, right? But the formula is from minus infinity to infinity.
சார் போயிட்டாரு, போடு போடு போடு. நீ வாயை திறந்து பேச வேண்டி டைப் பண்றது கருத்து.
I type faster than I talk.
அப்படியா? ஓகே சரி. அதான் அந்த இது வந்து அதாவது ஓரளவுக்கு என்ன பண்ணலாம்னு எனக்கு தெரியும். அது என்ன கேட்டிருந்தாங்க ஆக்சுவலி, எஃப் ஆஃப் டி இன்டூ டெல் ஆஃப் டி மைனஸ் ஏ அப்படி இருந்ததுல, அந்த டெல் ஆஃப் டி மைனஸ் ஏ வந்து அதை வந்து யூவி ரூல் வச்சு பண்ணலாம். அந்த டெல் ஆஃப் டி மைனஸ் ஏ இன்டகிரேட் பண்ணா 1 வரும் நமக்கு தெரியும். அந்த கண்டிஷன் கொடுத்திருந்தாங்களே.
ஆமா அது ஓகே.
அப்புறமா அப்புறம் கொஞ்ச நேரம் கழிச்சு சொல்றேன்.
हमको भी समझना है.
सीधा the del of t minus a integral minus infinity infinity equal to 1
எது யூன்னு எடுத்த?
u வந்து f of t.
ஓகே.
v வந்து del of t minus a.
dv தான் del of t minus a.
It is a kind of shifting theorem.
sorry. shifting ஆமாண்டா அதான்டா. என்ன பண்ணிட்டு இப்பதான் அமைதியா இருக்க? கேட்டா
என்கிட்ட லேப்டாப் இல்லைன்னா விளையாடலாம்.
ஏன் லேப்டாப் இல்ல?
அது ஏதோ செத்து போயிடுச்சு.
ஓ முன்னாடியே எப்போ சொன்ன மாதிரி இருக்கு. இல்ல நீ இல்லையோ தெரியல. நீ அந்த வீடியோல இருப்பேன்னு நினைச்சேன்.
நானும் நீ இருப்பேன்னு நினைச்சா. நம்ம ரெண்டு பேரையும் தான் காளிப்பவன் கூப்பிட்டான். You remember?
அன்னைக்கு வந்து பண்றேன்னு சொன்னேன். நான் வந்து அன்னைக்கே நான் பண்ணலடா அப்படின்னு சொல்லிட்டு வந்துட்டேன் நானு.
And I didn't.
நான் பரவாயில்ல.
ஆமா வின்ஸ்டன் மியூசிக் கிளப் சேர்றியா?
ஓ ஆமால, எனக்கு இன்னைக்குதான் தெரியும். பாப்போம். நீ சார் வரலையா?
தெரியவில்லை.
துரத்தி விட்டோம்டா டேய். உங்களை எங்களுக்கு பிடிக்கல போயிடுங்க, நாங்க வேற மேத்ஸ் டீச்சர் வச்சுக்கிறோம். இப்படி சொன்னா அவருக்கு புரியணுமே தமிழ் தெரியுமா? ஹிந்தில சொல்ல நான்
அவர் பெங்காலியா?
ஓ ஓ ஆதிரிகா தெரியுமா அவருக்கு? இப்பதான் ஒரு நியூஸ் பார்த்தேன்.
பெங்கால் வேற பங்களாதேஷ் வேற.
அங்க அது பெங்கால் தானே, பங்களாதேஷ்ல ரெண்டும் ஒரே மாதிரி தானே இருக்கும்.
ஏய் காரைக்கால்ல ஒரு நியூஸ் வந்துச்சு இப்பதான் பார்த்தேன்.
சார் you got
என்னது?
disconnected sir.
It got disconnected. I don't know. Internet problem. Hello.
Yes sir.
Yeah. So, sorry. Just 1 minute. Okay. Find the Laplace transform of del of t. Am I audible?
Yes, sir.
So what is the, if we go to the previous slide, previous or this one?
Sir, we can't see the presentation, sir.
You can't see. Okay, 1 minute. Now, is it visible?
Yes sir.
Okay. So this one is there, Laplace transform of del of t minus a. Okay. So next one is this one. Find the Laplace transform of del of t. What is the answer? So I will
Sir,
write
one.
the 1 minute.
Sir.
1 minute. Yeah. So 0 to infinity, the function is not defined at 0, so you can write 0 minus. Okay, 0 minus, since function is not defined, but actually you can write then 0 minus. Okay, it del of t e to the power minus st dt. So your answer is, I know, 0 minus infinity del of t minus 0, sorry, t minus 0 e to the power minus st dt. Now from here, actually you can directly write e to the power minus s into 0, so it is 1. So now if I ask, what is the inverse Laplace transform without this one? Okay, not from here. Inverse, now the inverse Laplace transform of, okay, that direct this one, that function is related to this one. Okay, so inverse Laplace transform of this one, 1 equals to, what is the answer? Del of t, correct? Have you studied
Yes,
earlier what is the Laplace, Laplace inverse transform of 1? Have you evaluated this one earlier?
1 by s.
1 by s, but here it is
Del t.
okay. So now this one. Okay, now I will ask you to find the inverse Laplace transform of one function. Okay, I need answer immediately. Okay, since you are already, you are master of this one now, the inverse
Inverse
Laplace
Laplace transform of 1 is 1 by s.
1 by,
Sir,
what you are telling
that
me?
is
Okay, tell
Laplace
me.
transform, no sir.
Inverse Laplace transform of 1, what is the answer?
What is it? I don't know sir.
Have you studied earlier inverse Laplace transform of 1? You have not studied actually. Earlier you have studied only Laplace transform of 1, that is 1 by
yes,
s.
sir.
And then inverse Laplace transform 1 by s is 1. But I am telling here is different. Laplace inverse transform of 1.
Yes,
Okay. So now next one problem. Okay, it is known very simple problem. Okay, now find the inverse Laplace transform of, okay, this one, that means 4 by, sorry, not 4, square by this one. Quick, I need answer immediately. Anna,
Cos 2t.
what is the answer?
Cos 2t.
Okay, everybody agree with
Sir,
this
it
one?
should be only s, right? No, sir, it is not cos 2t.
S by S plus S.
If I write s, then
Yes,
it is
sir.
correct.
Yeah, yes, sir.
That
Oh.
means if that
Yeah,
fellow is too hurry, Anna. Okay, If it is this one, s by s square plus 4, then your answer is
Now
correct.
it's cost rotation.
But my question is different. S square. What is the answer? Okay, I will help you. Okay, na? Little bit, not too much. S square plus 4 minus 4. Okay, s square plus 4. So it is Laplace inverse transform of 1 minus 4 by s square plus 4. I don't know the next step. Actually, if I given this one first, then if we discuss the dd function, then actually that was actually most interesting one. But now it is don't know you. What is the answer, sir?
Sir, is it del t minus
No, you just studied del t. Now why you are using del t? What is your roll number?
sir 33?
Right. Okay, next. Let us see what is the answer. Laplace inverse transform of s square by s square plus 4. S square divided by s square plus 4. It is not cost to. Okay, that is.
Sir, I am getting del t minus 2 sine 2t.
Okay. I know this is the answer. Okay, but my question actually different. Have you studied earlier without using the real delta and find this one? This one just now you have studied. Okay, now. My question is, what is the answer? If you don't know the Laplace transform of the delta function. Not this one, mechanical. Okay, tell me quick.
Normally, inverse of 1 is by s. We have studied.
Yeah.
Here it is dt.
Yeah. It is itself. F of s is 1. Correct. I have not studied earlier. Correct. So I think so. Capital F of s. If it is not constant, you have studied so much. But if it is 1, this is the first time I think you are seeing this problem. Correct. Earlier, always it is either s or something. So if you don't know the delta function, I think you are not able to answer. Okay. This type of Laplace inverse transform functions form. Okay. However, this is correct answer. Okay. And you can write in the direct delta form itself. Okay, directly you can write this one, but you can up to this one is also okay. So del t minus twice sine of twice t. Okay. So this one actually you have not studied earlier. This is the first time you have studied the Laplace inverse transform of 1. Laplace transform of 1, if I ask, immediately you can able to answer. I know that one. But here it is, the question is not that one. Inverse Laplace transform of 1. So that one is the direct delta function. Okay. So now that one, this type of function. Okay. Where only constant is there. So say if it is not 1, if it is 2. Okay. If you have doubt, just now tell me the answer. Let us see. 2 square. Correct. 2 square. That is 8 minus 8. You understood why you are doing 8. Okay, now we need a square plus 4. So now it is 2 minus 4 by or something by this one. This side is no need to discuss. Now you tell me the Laplace inverse transform of 2. What is the answer?
We'll try to as 1 plus 1 and do it separately, sir.
Very clever fellow. Okay, so that 1 plus 1 means delta t plus delta t.
2 delta t.
So 2 delta t. Are you sure?
Yes,
okay,
sir.
you have 1 day time. Okay, tomorrow I think day after tomorrow we have one more class. Okay. So if your answer is correct, no need to discuss. If it is not correct, if you want to change your answer, we can discuss in the next class also. Okay, na? Just inform to your friends also. So Laplace inverse transform of 2. So if it may be one homework. Okay, na? Just for practice, no need to send anything. Okay, na? So find the inverse Laplace transform of, okay, 4 square by square plus 16. Okay, let us see what is that answer. Okay, so find this one, inverse Laplace transform. Okay, so now we'll move to the next one. Okay, so next one is this form. Okay, I think we can complete only one theorem. Okay, now we will study two theorems, that is called, that two theorems, these are named initial value theorem. What is that one? And another one is final. Okay, so that is IVT and this is FVT. Okay, so why you have to study this one? Okay, this one we have till now actually what we have done actually, what is the nature of the function? Okay, say the function f of t. What is the nature of the function when t tends to 0? That is, what is that? What is the meaning of this one? What is the range of the Laplace transform? Quick, beta. Should one fellow should answer at least. Anyone, no problem. What is the Laplace? What is the range of the Laplace transform?
0 to infinity.
0 to infinity. Now I have written f of t tends to something. I have not written anything. When t tends to 0, what is this meaning? That means what is the nature of the function f of t at t when t tends to 0? You can identify. Correct. So, and what is the t then t tends to 0? What is the meaning of this time? Meaning you can say something. What is that called? What is that term? Initial. Okay, na? So initial situation, what is the nature of the function? You can identify or you can check. Okay, you can investigate the function's nature at when t tends to 0. Okay, so t tends to 0 means t tends to 0 minus and t tends to 0 plus. Okay, just few minutes back we have already discussed, we have already faced one problem, that that problem, then this one is not defined, that means infinity, when t equals to 0. So in that case we have considered t minus 0. Okay, you can consider also t plus 0, but since the definition of this that Laplace transform is 0 to infinity, so we have taken left hand side. Okay, so now if you are able to find, or if you can guess, or you can predict, okay, the system that is f of t, this is the original function. If you can able to predict the nature of the function, nature of the, is it again it's gone, just 1 minute. Okay, okay, when t tends to 0, you can check the nature of the function or behavior of the function, that f of t you can predict. Okay, so for that one you no need to define this function. If it is complicated one, you just take the Laplace transform and then some relation between this f of t and capital F of s you can find. Then through Laplace transform, that means this one, you can check the initial condition or initial behavior of the system at t tends to 0. That is actually this theorem will give you the concept, that concept, that's why it is known as initial value theorem. Okay, next one is, what is the next one? If you have listened that one, then you can answer this one. What is the final value theorem?
T tends
Not
to
infinity.
infinity. Sir.
So what you will get at t tends to infinity? The nature of the system or behavior of the system when t tends to infinity. But t tends to infinity, you no need to do t plus infinity or t minus infinity. Why?
Because that is also infinity, sir.
That is also infinity. And one more, the function del of t is defined. There also it is defined. So that's why these two actually IVT or FVT both are related to, okay, both are related to actually you will get through the del of t. Okay, so you can predict the behavior of the system f of t when t tends to 0 or when t tends to infinity. These two, without finding the nature of this one or without finding the without knowing the system behaviors. Okay, so that is also through a Laplace transform. Clear? So that is also through Laplace transform. Okay, but that's all today. It is boring now. Okay, that will be theorem, statement, and proof only. So I will discuss that two only in the next class. Okay. Okay, so statement and proof in the next class only. So that's all from today.